and Anthony Ferrara, and blending together to talk about writing clean software and then also looking at some of the metrics. And I had their permission, so don't worry, it's good. So as I mentioned, my name is Jeremy. You can ping me on Twitter later. And I work at MongoDB, working on the driver and Doctrine and stuff as well. And Doctrine is probably the most common place where I apply the principles here with refactoring a lot of the open source libraries that we work on. Not so much for the MongoDB driver, because that's in C. But the topics I want to cover, and basically, let me just pull out my pointer before it runs out of batteries. I want to talk a little bit about training. So there's some exercises we can do to write cleaner software. And then as well, then get into some of the metrics, basically Cydomatic Complexity, NPath Complexity, which is the two of the most common ways that we can measure, most importantly, measure with software programs and be able to see how complex they are. So we can pipe that into the tools, then give us feedback on how, over time, maybe how complex our software gets. And basically, these gives us the excuses to say that, yes, this other framework is a lot worse because it's more complex, it's more messy, and Symfony is great. So those are the excuses that we can use to feel good about ourselves. I'm not going to be talking about this, but I always like to start with an XKCD comic of, it's very difficult to actually write good code. There's a lot of decision making to do. But hopefully by the end of this, and a lot of these are going to be suggestions and ideas, so don't try and follow everything to the letter. You'll go crazy. But try and take away whatever you think would most benefit your project or your team. So to start off with training, I mentioned I pulled some things from Guilherme Blanco and Rafael Doms have talked about object calisthenics. I think they're really good principles and exercises to apply, so I want to start with those before we get into the metrics. And these come from a book not meant particularly for PHP developers, but called the ThoughtWorks Anthology. This is like a collection of essays on software design, one of the many books where we get all these principles that we take for granted today, and design patterns and such. And the one that I specifically talk about, object calisthenics, Jeff Bay, who is a Java developer, came up with these exercises. This is probably at least 10 years old by now. And he opened his essay and he said that we basically know what good software looks like, but we may have a hard time putting it into actual rules. So he's mentioned the things that we want loosely coupled things, so having components that aren't dependent on each other as much as possible. Have a very cohesive bundles and components that work well together. Getting rid of redundancy, so the reasons that we refactor our code. These are all the things that we look for in good programming. As well as testability, which I'm not going to push on you. I'll let the grumpy programmer do that. But also another important thing is readability. So even if the code is very functional and very performant, if it's not readable, it's not maintainable, that's also a big problem, particularly in open source. If Symfony was a lot more complicated, to read the code and get through it, then it would be much more difficult for people to contribute and have a big community behind it. So he came up with this essay of 9 rules to basically kind of put these concepts into actual things that we can follow. And the origin of the word, so object for object-oriented, of course. And then calisthenics, which is a Greek word, or has a root in the Greek word for being exercises. So object-oriented exercises. This is the only way to make this sound exciting, but it could be quite boring otherwise. And I will say, so I'll say 2 things. The first thing is these were written with Java in mind. So some of the original rules are adapted for PHP. Some of the rules of like how long a class can be, how many properties you can have in a class, were much smaller for Java because they have different language functionalities where with PHP we have less tools at our disposal currently. So we have to make special allowances because PHP. But additionally, these are exercises to follow, so don't follow these to the letter and fire your coworkers because they can't follow these rules. So just take them as tips and suggestions. So I'll start off these. I have these icons for hands, so we'll go from 1 to 9. So the first one, which is actually I find fun to do for refactoring Doctrine, is to have 1 level of indentation per method. And the goal here is to avoid code that looks like this. And maybe specifically, hopefully, if you've worked at Symfony forms, and maybe in your controllers you're dealing with forms and then doing redirections and things like that. In this case, I pulled this from OpenSky when we were migrating to of the code or the instructions through the function kind of follows a very complicated tree structure. And this also is very easy to get out of hand in a larger function. So if we decide I want to be strict, I don't want to use the else statement, so how does that change the shape of the code? And hopefully you find this more readable. So in this case, I would still start off by finding the product that I hope to modify. And then additionally, instead of having that at the else statement, I'll kind of catch the else early. And so I know if there's no product, immediately return. And so usually this takes advantage of ways that we can return early from the function and end the control flow there. And so the flow, instead of it being a tree and having a large tree shape, of course, it follows more of a line, a straight line down that periodically might throw an exception or return like that. And additionally, sometimes when if you're doing if-else, maybe you could say it's still cheating, you're still using conditions here, but I like using ternary statements for when you're doing assignments that way. But this also makes the code much more readable. It keeps it less likely to be falling all the way over to the right, and then you have to scroll left and right to see some of the code that's all the way off screen. And it generally just makes it easier to maintain and test as well. And we'll see later when we talk about the metrics, this makes it easier it makes the code path less complex, so it gives us better code metrics. So enough about those. These are some things without code examples behind them. Jeff's third point was to avoid using primitives for things. And this is, in PHP, this is not to be taken to the extreme. So it's not to say don't use strings, don't use integers and things. Because if we use objects in PHP for everything, it'd be very expensive. But he's more talking about using primitives for our domain objects. So the things that might have some context attached to them. So the reason, the best example perhaps is you're encouraged to use a datetime instead of using a timestamp integer. Because the date has extra context to it, it may have a time zone attached. Similarly, if we have logging, we might have a message class that has also the priority, or things like currency, where currency is not just a float, or hopefully not a float, it's not just an integer, but it also has the currency type, and maybe there's additional exchange rate information and things like that. So his suggestion is to replace these with value objects. In PHP, I think 5.4, there's a datetime immutable. And the value objects ideally are not modified. So similar to integers in strings in PHP, they basically literal values. With a mutable datetime object would be, instead of modifying the datetime object, because we might pass it into a function, if it's immutable, we don't have to worry about the other method modifying the object by reference. So this makes our code more predictable. We don't have to worry about passing, if we're using objects for these domain objects, we don't have to worry about them being modified inadvertently. So kind of use constants as we would integers and strings. And this is important. It facilitates, so we know we can type hint against these things now. And additionally, it makes the code more self-documenting. So instead of having an integer and having to know that's a date, we will use timestamps, or we'll use currencies instead. We know the context at all times. Fourth suggestion, and this comes back to another design pattern called the law of Demeter, is to have one, in PHP, it's the object operator, the arrow, but in Java it would be one dot per line. And the goal here is not to, if we follow the law of Demeter, it's not too much applying, not anything against fluent APIs or anything like that, but talking about our dependencies. So if we have a service, we basically are allowed to talk to our own dependencies explicitly, but we should not make assumptions about the things they are connected to. And this mainly comes back to not circumventing the encapsulation of, if I am calling, let's say if I injected a entity repository, but I also use it to access my entity manager in Doctrine, I put this into a controller, it would be a violation if I went through my repository to get my entity manager and then did something else. Instead, I very clearly depend on both, so I should have both injected into me. And if we follow this, if we obey this rule and not keep chaining and going on, and we'll see on the next slide, it'll basically lead us to only have one access per time, unless we're using fluent APIs like query builders and stuff. In that case, it's perfectly fine. But a good example, the simple example for this is if we were trying to get the user token out of the security context, we might, in our controller, go through the container, get the security context, get the token, get the user. And this makes several assumptions about the type of token that is a token that will have an actual user attached to it, that this is not null as well, that we do have security enabled in these things. Additionally, from the side of maybe a model class, if I was going through my related entities or my related documents and then accessing some of their fields, which I think is very common to do in Twig, which probably makes it easier because it catches when things might be null. But in this case, imagine if the profile did not have an avatar. So this code would obviously have a fatal error. In the same case, if the token was null, likewise, this code would crash. So if we apply the principle of not chaining up our dot operators and going on this, it could lead us to, we could just have these helper functions that do the checks for us, or have more direct dependencies as well. So if the user knew how to get the avatar URL and it took the action inside, it makes our application code, which would look like this, much more readable and concise. So that's the goal of this tip. The fifth one is not to abbreviate. And this is important mainly for code readability, nothing to do with functionality. But the questions to ask are, why are you abbreviating? Is it because if method names are too long, if you ever use the word and in a method name, you're probably doing multiple things at once. So that's a hint that you should refactor those into two separate methods. Often in a class, if we have the common prefixes repeated all over the place, there's probably some redundancy there, or maybe there's duplicated code. If every method started with the same process and you have that in the name, that hints that you can probably extract the method out. And when the method names are too long, as I mentioned, if hashes password and sends registration email is one method name, things like that are too long as well. Additionally, if we have classes such as like an order class that is responsible for shipping itself, we can, if we have the methods, usually make the methods be verbs it'd be redundant to say order has a ship order method. So we just have a ship method, it just ships itself. This is also relevant if we are naming variables and things to have readable variable names, so that when our coworkers come by, they don't have to ask why there is a foo and a bar and a baz variable, or things, or just all these abbreviated names for variables. The sixth point is to keep your entities small, and not necessarily your database entities, but your service classes. Those are the entities in Jeff Bay's context. And Rafael and Guilherme have adapted these rules. So in Java, it was much less. Jeff's suggestion for a Java class would be less than 50 lines. And that's because there is not the need for doc block comments as much, because everything is type hinted. But in PHP, we make extra allowances because the language is not as concise, and we usually have to have the documentation blocks. And so the values were increased a bit, and these are just guidelines, suggestions. But this, generally having a service when you know the feeling when you have a service class and or a utility class or something, and you have dozens of methods, and you're doing autocomplete, and there's so many different methods inside that class. That's a hint that that the class is probably doing more than it should, or more than it should be responsible for. Additionally, if we look at PHP as namespaces instead of packages in Java, but if we have a single namespace with many classes, there's probably ways that we could better organize that and make it easier when someone is looking for functionality, similar to the Symfony components, where when we want to look for an exception inside of a particular component, we know we go to the component namespace and then the exception namespace after. Or things like inside of a bundle, particularly, we have the namespace where we put our controllers, where we put the dependency injection configuration, etc. And the ultimate goal is just have our packages be meaningful, either components, and just the classes within them should be related to each other and be cohesive. And again, the goal here is it makes it readable and maintainable for the rest of the team. And this is the seventh tip, also increased from Java from 2, which would be very unreasonable in PHP. So having your classes, or in this case your services, think of your services having at most 5 or a handful of dependencies. Definitely having, this is particularly at OpenSky when we got very excited about using all of our controllers being services. And the minimum controller would need at least 4 or 5 services, because you would need routing and templating in the security context and a few other things, before you need even then doctrine as well. So just doctrine, routing, and templating, you're already at 4 or 5 services. But think of more so the services that are not so much the controller services, but other classes that actually have the business logic of your application. Those, it's generally a good rule of thumb to know that if you're injecting dozens of services into a single service, there's probably also too much responsibility happening inside. And this maybe goes hand in hand with, if you exceed this rule, you'll probably also have much longer classes as well, because you're using all these things. So instead, the solution is to decompose, take these large classes with many dependencies, decompose them into smaller things. If we're frequently injecting something that works on a user object, and we have a user service, but we're also sending in the document manager or the entity manager, because we have to do a flush with Doctrine, it's much more straightforward to just put that responsibility for the flushing and the persistence inside the service that works with users. So then we, instead of injecting 3 dependencies, we go down to 1. And that in turn makes the calling code a lot cleaner as well. And so again, not something to follow for your data models. Will have more than 5 certainly, but your service classes, to be mindful to keep them smaller. The 8th rule, have first class collections, and this is quite similar. So if you have a class that represents a collection of something, it should probably not have other responsibilities. And this is best illustrated in Doctrine. So we have the collection interface in Doctrine that does basically just is responsible if you have a many relationship. You'll have the collection interface, either persistent or an array collection, depending if it's from the database or from PHP. And that will be a collection of it has basically one property, which is the array of elements inside. And it provides an object-oriented interface for all of the operations you would do on that collection. And so in this case, a first class collection is just a class that represents the collection and the behaviors that you would do on the things inside. And so again, the best example I can think of, Doctrine's array collection. Inside we have basically all the array PHP methods that you would expect to find, like filtering and mapping and slicing. And so this again leads to preventing having a class that did both things and juggled the responsibility of multiple objects, of collecting multiple objects and doing all these other dependencies with them, would lead to a much bloated class, and this keeps things much more loosely coupled. And the other benefit here is that we can use this everywhere else if there's plenty of PHP interfaces to implement to make this as convenient as possible. And lastly, the advice of having no getters and setters for class properties. So I would again say not for your data models, but think about this more from for your service classes. And particularly if you're using dependency injection and the things that you need to create your class are given upfront in the constructor. But not having setters and this goes hand in hand with, if I have a service class, the 2 concepts that I want to balance here are, one, I don't want someone else to change my state inadvertently from the outside, that they should not have the responsibility to do that. But additionally, if I have getters available to me, that means that other people can go pull the things inside of my service away from me and do the logic elsewhere. So if instead I follow the principle that when I create a new class, I make everything private by default, I keep everything encapsulated, and only open it up when it's necessary, that makes sure that the logic for what I'm trying to do is kept inside my class, instead of other people being able to make decisions outside. And it also keeps any decision about my state is done inside. Again, for data models, absolutely you will want getters and setters for things. And this follows well beyond PHP, well beyond Java. Smalltalk is a very pure, abstracted, object-oriented language. Alex Sharp is one of the authors of a Smalltalk book, and his sentiment was that in procedural code, yes, you go and you call getters, you get access variables, and then you make decisions about them outside. But if it's object-oriented code, you should be telling the objects what to do with themselves, instead of doing the decision-making outside. And this kind of goes hand in hand also with, by following this, you're less likely to do more behavior in your controllers as well, because you'll have to use your services for them. That said, this is PHP, so there's exceptions. The places where you will want to use getters and setters for things, even in your services. So in some cases for dependency injection, when you have optional dependencies and you don't want to give them inside your constructor, one of the things we used at OpenSky was interface injection. So having every class, similar to what Symfony does with container aware. If your controller is container aware, when it constructs the controller, it always injects, it calls set container on it. So similar to that, those are cases where yes, you need a setter method to be able to change and add the dependency after you're constructed. Also with lazy dependencies as well, you'll want that. For any transformations, so if you're, as you're setting something, if you're finding your need to transform the data that comes in or wrap it in something, So in PHP, we have limitations. We don't have things like in Python, you would have decorators, and you could just wrap functions and apply the transformation logic to that. But in PHP, there's not really a good way to do that without extending and wrapping things. And then lastly, again, the decorator pattern as in Doctrine proxy objects. So if you've seen those, when you have a proxy object, we extend your model class and we override all the methods and all of the getters. Before we call the actual getter to return the property, we'll initialize the proxy object. And similar to how I believe the lazy services in Symfony might work, where they lazily initialize themselves by decorating essentially the main methods. So these are some exceptions for that. A last rule of thumb to think about is not to have utility classes. So these classes, maybe not so much today, but because it's very easy to create services. But in the old days, having a utils.php file somewhere in your project that has all these functions that have nothing to do with each other. Maybe one does the slug something, the other one returns a string that says how many, this is like 6 seconds ago or 8 minutes ago, and you just lump these all together. And now you can hide them in twig helpers and things like that. But these are still a problem for projects. We end up with these classes that just grow and everybody dumps stuff into there because they know everyone can get away with it. But in addition to just having no reason for existing, they're just really just functions. They're typically, since they're not tied to objects and they're working outside, this probably goes hand in hand with they probably access objects and then do stuff with them. And the thing they're trying to do, especially so if it's something like calculating time ago, maybe that's better put on a date object or on if you have some custom date object rather than having extra utility functions that you call for things. So this is not always the case, but usually a smell that you're violating encapsulation by having these things. Okay. So that wraps up the calisthenics tips. Now to talk a little bit about metrics and how we can not just look. So I could look at code and I could say this code sucks, it's messy. But this will give me actual numbers, so I can say this code sucks because it is this metric. A good metric, again, to start with, the only good metric for when we do code reviews and pull requests is how many WTFs we get reviewing the code, complaining about this stuff. So if it's good code, there won't be too many of them. But we know bad code is going to have a lot more comments and critical reviews. So there's other things besides WTFs we can measure. Things like number of white space, how much documentation, percentage of documentation to actual code, which would give us a hint that we hired this person, they're writing all this code and not documenting it. And when they leave, we're going to be screwed because we have no idea how it works. There's things like function points, which are ways we could just measure complexity of functions, which are helpful more so when we're planning a project. Okay, there's actually bullets here, yes. Source lines of code, code coverage for if we combine this with tests. And over time, we could see this code coverage increase, decrease, which components have the most test coverage. Bug density usually correlates with code coverage, but this might tie in with, as bugs are opened, frequently which components are they opened for. So we know those are the ones that are probably the sloppiest. And so if we have development time, we want to put them towards the things that are getting the most bugs. Cohesion and coupling, so code that interacts with itself. So if you're the Aura framework, you'll have absolutely no coupling. Everything is totally separated. Something like Symfony, maybe the components do have some interdependencies. Cydomatic complexity is one of the things that I'd like to talk about, the metric. So basically, we're going to look at how many conditions, how many if statements are in the code, and that kind of tells us how many tests we have to write to test all the bits of the code. And then you might have your custom constraints, like your coding standards, things like that. Those are all metrics that we can measure and then contribute to some idea of how the code quality is. So to start with cydomatic complexity, this is the easier of the two. The second one is NPath. This is basically the number of decisions that happen inside of a function. So any if, any for switch statements maybe. And this is a general indication of how complex something is. So we have a function that does a lot of decisions inside. We know it's generally going to be more complex than something that just maybe returns a formatted string. This obviously be a trivial function. And a spoiler, usually things with more decision points are prone to having more defects. If we look at most projects over time, if you look at the amount of bugs that get fixed or reported against things, it's usually in the more complex code is the one that has the more decision making. So I will use trivial examples because we're more focused on just counting the if statements here. But you can do this with any, we could do this with the controller code, anything. You can do this with any code. We start at 1 because we're calling the function, so that's the first decision is we entered the function. And then every time we have a condition, we just add an extra decision point. And then, so this basically counts not the total paths through the program, because there's many more paths here, but just anytime we're checking conditions here. And we'll see the final else case does not actually count. So there's 1 entry point, 3 conditions. So our cyclomatic complexity in this case is 4. And a rule of thumb, and this is somewhat adapted for PHP by Anthony Ferrara. So if you have a function that's 1 to 4, it's considered low. Low complexity, there's probably no bugs. You can read it and know it very easily. On the other side of things, if you're 11, 12, if you're inside the doctrine unit of work, this is in the dozens and hundreds. Very high complexity, probably more bugs, and very hard to maintain. But this somewhat relates to NPath complexity, which is probably more important because this tells us cyclomatic complexity is good as a general indicator. This is good for telling us how many tests we have to write. So this is the number of, similar, it's based on the number of decisions made, but it's counting really the number of paths that we might take through a function. So if you remember the previous example all the way in the beginning, when I was counting the shape of the code and I said there was the nested if statements and such. So if we followed the tree, there were all these different paths that we might take throughout the program. And after we refactored it and we had if, return, our path was much simpler. It went straight down and it periodically branched off to the left. But this is more relevant to us as software developers if we're writing unit tests. If you're not writing tests, then who cares? But with NPath complexity, this is telling us how many, if I have a higher NPath complexity, that means I need more unit tests to cover all the different things that my function might do. So your goal as a software developer should be to, you want to write as few tests as possible, but still get good coverage. So you should aim to keep this number small if possible. So if we take the same example as before, the NPath complexity, in this case I want to count the actual things that might happen inside. So the different, these are all with else statements, so there's 4 possible things that might happen. A and B, just A, just B, or neither. So in this case, they happen to be equal. So that's fine. But if we find that we just take the same code, and we add 1 more condition after, the cyclomatic complexity goes up by 1, because we have 1, 2, 3, 4, 5. But the NPath complexity was everything before was 4. But now for each of those, there's 2 possible outcomes here. So I've just doubled, by just adding 1 if statement, I've just doubled the amount of possible paths through the code. And in the worst possible case, we just have a whole bunch of if statements. And in this case, we would need to test, since these are not returning, there's essentially